Welcome to day 2 of our review of Unit 3 from last year. Homework for tonight will be packet page 10. And we want to be taking homework out and also have calculators out as well. We'll be using those today. So the first one, we wanted to find the vertex and the axis of symmetry. Calculator way to do that, just put in a graphs page. Do menu, analyze graph, either maximum or minimum, whichever one you have. So in this case, we had a minimum, we had 1.5, -6. And then, so your axis of symmetry, if that point is 1.5, -6, will always just be x equals whatever the x value is of your vertex. The algebraic way, you can do -b over 2a to get the 1.5, and then sub it back in the equation to get the -6. For number 2, as x goes to -infinity, so that means we want to look far to the left of the graph. When we look far to the left of the graph is going upwards, so f of x is approaching infinity. As x of x is approaching positive infinity, so that means we want to look far right on the graph. Our graph is heading downwards, so that is approaching -infinity. Our intervals of decrease would be this interval and this interval. So that would be when x is less than -5 and when x is greater than 1. That would be with inequalities. And then if you wrote it in interval notation, you would have rounded -infinity and then -5 rounded because we're not including those turning points. And then likewise 1 to infinity for the other one. And then our interval of increase is that interval in between. So that's from -5 to 1. Notice with these double inequalities, both inequality signs are opening towards the bigger one, towards the 1. Number 3 on the homework, we don't have 1 in front of the x squared, so we can do our a times c method. We get 24. So we want to multiply to 24, and we're looking to add to -14. So you can do the number you want to multiply to, 24, divided by x in a graphs page, and do a control T, and then look through and find the pair that adds to -14. That would be -2 and -12. That allows us to split up the middle into -2x and -12x. Doesn't matter which order you put those, so if you reversed it, -12x, then -2x, you'll get the same answer in the long run. So the way I had it with the -2x first, I was able to pull an x out, automatically put 3x minus 2 on the other side, and then decide what would we need to have out front, so if we were to distribute it, it'll give us the -12x plus 8, and that would just be a -4. One of your parentheses is the 3x minus 2, the other's the stuff out front, the x minus 4. Notice this was not solving. It did not have an equal sign, so we wouldn't set them both equal to 0 to get something because there was no equal sign in the problem. All we wanted to do was factor. And then the last one, because you have a 1 in front of the x squared, we can just do it as a multiplies and adds 2. So you had 8 and 2, so x plus 8, x plus 2. Down on the bottom, if it's telling you to do it in simplest radical form, that is a clue that it's not going to factor, and we should use quadratic formula. So our a was 2, our b was -6, and our c was 3. And we were able to pick those out because we already had it equal to 0. Fill those into your quadratic formula, which is right on your reference sheet. It's key to note that we always need to put this b in parentheses and then square it, particularly in a case like this where b is a negative. Put in the numbers under the square root, but not the square root itself, and we get 12. Then do your menu number factor for 12, and you'll get 2 times 2 times 3. Circle the pair of 2's, 1 comes out front. So square root of 12 will really be 2 square root of 3. So now we're up here. That is technically in simplest radical form. You could leave your answer like that on a free response question and get full credit. Or you could divide them separately by 4. 6 over 4 reduces to 3/2, and then the 2/4 reduces to 1/2, so you could have square root of 3 over 2. So either of these two would get you full credit. All right, so we're going to be going over to the next page, which should be page 5 in your Unit 3 review packets. And first one we're going to look at is seeing how to solve by completing the square. This problem will be similar to homework question number 1 tonight. So on your homework, if you get stuck on question 1, this would be the good spot to look back. So you can only complete the square if you have a 1 in front of the x squared. We have that here, so we are in good shape. Our next step is we want to get only the x's on one side. So we're going to subtract that 24 over to the other side. So we'll have x squared minus 8x. Then we're going to leave a little space, and we'll do the equals negative 24. Now comes for the actual act of completing the square. We're going to take half of our b value and then square it. And I would suggest to show some work off to the side for this. It'll help us in one of the next steps. So we're going to do 1/2 of negative 8 and then square it. Well, half of negative 8 is negative 4, so we're going to square negative 4. A negative times a negative is a positive, so we get positive 16, and that's what we're going to add in this blank. But you can't just add something on one side of an equation, it's now unbalanced. So we've got to add that 16 to the other side as well. Now here's where if we showed this work over here, it makes our next step on the left side easy. The whole point of completing the square is to turn the left side into two factors that are identical. So instead of just writing as something in parentheses times itself in parentheses, we can just jump right to writing it as that thing in parentheses squared. We're always going to have x here, and then the number with x will always match whatever we squared over here. So if you show that little bit of work off to the side, it makes this step easy. So this is just going to be x minus 4 being squared. If we combine our like terms over on the right, we get negative 8. And now our goal is to work to get x by itself. So we're going to take the square root of both sides. When you elect to put a square root in a problem, you have to remember your plus minus. And we put that plus minus on the side that did not have the squared. The square and the square root wipe out on the left, so we're going to have x minus 4 equals plus minus square root of negative 8. So this is going to be x minus 4 equals plus minus. A negative under a square root comes out as an imaginary, so we'll have an I out front. And then we'll have 8 left over inside. So if we go to the calculator and do a menu number factor for 8, we get the prime factorization of 8, which is just 2 cubed. So we'll have 2 times 2 times 2. We'll circle a pair of 2's. So this will now be x minus 4 equals plus minus. One of the 2's will come out front from that pair. Usually we put it in front of the I, so we'll have 2i, and then we have that 2 we didn't circle left over. And then our last step is just to get x by itself. So opposite of subtracting 4 would be adding 4. On the left side, we'll just have x. And you can technically put the plus 4 at the end or the 4 in the beginning. I tend to put it in the beginning, then it looks similar to as if you had done this with quadratic formula. So we'll have 4 plus or minus 2y square root of 2. If we were to graph that original equation, we would see that it actually doesn't cross the x-axis at all because these roots are imaginary, they're not real. So if you have trouble on homework question number 1, tonight this would be the place to look. All right, we are going to skip the question on the bottom, and we're going to move over to the top of page 6. So on page 6, we're given a equation that is in standard form. This is a quadratic. And we want to put it in vertex form. So first, off to the side, let me just give you a random example of an equation in vertex form. So say we had something like y equals 2 let's say we had x plus 7 squared minus 3. So first thing I want you to note about vertex form, the value out in front of the parentheses, which we often call the a value, will always match the a value when it is in standard form. So in this particular example, we know that our vertex form is going to be y equals 1/2. We'll have something in parentheses squared, and we'll have something added or subtracted on the end. Now, the vertex form makes it easy to pick out the vertex based on transformations that are happening. If you have a plus 7 inside your parentheses, that means from the origin, the vertex shifted left 7. Because inside the parentheses, the sign is opposite of what you would think. So a plus actually goes to the left, a minus shifts it to the right. And then at the end, that's a shift up or down, and it's exactly what you would think. So minus 3 actually makes it go down 3. So in this example, if from the origin you're going left 7 and down 3, then our vertex would be -7, -3. So knowing that, what we're going to do, we already have the value out front. On the Regents, you have your calculator, so we're just going to graph this and do menu analyze graph, either maximum or minimum, to get the coordinates of that vertex, and then we'll use it to write the equation. So let's go over to our calculators. We can do Control Doc to get a graphs page. So in the graphs page, we'll put in that equation. So we'll have 1/2. And you can be putting this in on your calculator as well. 1/2 x squared minus 5x plus 12. So then we'll do menu, analyze graph. And in this case, we have a minimum. So we'll select to the left of our minimum. We'll select to the right of our minimum. And it tells us what that minimum is, which is our vertex, or in other words, our turning point. So we get 5 and -0.5. So if we go back here, one of the things we had to do in the question was state the vertex. So our vertex is 5, comma, -0.5. And you could do either -0.5 or -0.5. So that means that we want to show in our equation that we went right 5 and down 0.5. Well, if left 7 was adding 7 on the inside, right 5 would be subtracting 5 on the inside. So we'll have x minus 5. And then down the half, we should be subtracting on the end, so we'll have minus the 0.5. So we now have our equation in vertex form, and we have our vertex. These ones are really easy to check your answer to see if you're correct. You can just graph the original equation in standard form, and on the same graphs page, graph it in vertex form. If the graphs land right on top of each other, then you know you did it correct. If they're not on top of each other, you know you had an error and you need to fix it. Now, we're going to do one more of these, but questions like this are what you'll see on homework question 2. So when you're doing question 2 on the homework tonight, this page would be a good page to look back to if you are stuck and you can't remember how to do that particular question. All right, down on the bottom of page 6, same directions. We want to put it in vertex form and state the vertex. The fact that our a value in standard form is 3, that's going to be our a value in vertex form. So we're going to have y equals 3. We'll have something in parentheses squared, and then we'll have something on the end as well. So let's go to a graphs page. You can add a new graphs page if you want by doing Control and Doc. So Control Doc adds a page. We'll add a new graphs page. We can put our equation in, the 3x squared minus 6x plus 3. We'll do menu, analyze graph, minimum. Lower bound, select something left of the minimum, upper bound, right of the minimum, and we get 1 comma 0. So the second part of the question, state the vertex. Our vertex is 1 comma 0. So that means on the inside, we want to show that we're going right 1. When you go right 1, we should subtract from the x, so we'll have x minus 1. And on the end, we don't want to go up and down at all. Hypothetically, you could put plus or minus 0 if you wanted, but that's not really doing anything. So if it was a multiple choice, say, you wouldn't see anything written on the end. In a free response, it would not be wrong to have either plus 0 or minus 0 on the end, but again, you likely would not see that in a multiple choice question. So on homework question 2, any of the questions from page 6 can be a good place to look back to help you with that. We're going to jump ahead to page 8. So we want to go to the football example on the top of page 8. So we've got a football. It leaves the hands of the quarterback and is thrown to a receiver. The graph shows the height h after the ball travels x yards forward. So we want to find the equation of this in vertex form. So we're going to have y equals, we don't know our a value this time, so let's just leave it as a. But we do know the vertex. From the origin, this vertex is shifted 10.5 to the right and 11.5 up. So if we want to go to the right, we should be subtracting from x. So we'll just have x minus 10.5 in parentheses squared. And if we want to go up 11.5, we'll just add that on the end. Well, now we just need to find a. In order to find a, we need to know another point that we can sub in for x and y and find a. Kind of like when we sub in an x and y to find b in y equals mx plus b form. Well, one of the nice points we have on the y-axis here is 0, 6. So our goal is going to be to sub that in for x and y so that we can solve for a. So the x is 0, the y is 6. So where we have y, we're just going to fill in 6. Where we have x, we're going to fill in 0. And now the only missing thing is the a. Well, let's start by subtracting the 11.5 over. And the reason I suggest to do that first is that number we're going to get from the parentheses needs to multiply the a first and not add to the 11.5. And a common error I will see is people will add that number that we'll get from the parentheses to the 11.5 before multiplying by a. So if we subtract that 11.5 out of there, there's not even the threat of making that mistake. So we'll have negative 5.5 equals, take a moment in your calculators and put in our 0 minus 10.5 squared exactly as it looks there. We'll do that on a calculator page. And we should be getting 110.25 for that. Well, we've got multiplication. Opposite of multiplication is division. So a we'll get by just dividing those two things. So if we go over to our calculator page, we'll have minus 5.5 divided by the 110.25. Okay, notice we get a nasty decimal. The question does not say we should be rounding at all, so we want to switch that back to a fraction. We can switch a decimal back to a fraction by going Menu, Number, Approximate to Fraction. The command in the calculator looks a little funky, but if you hit enter, it'll switch it back to a fraction for you. So we have negative 22 over 441 for that value of a. So now just like when we do y equals mx plus b form and we solved for b, finding b isn't the end of the problem. You got to write the actual equation. Same thing here. We got to write our equation with that a filled in. So we'll have negative 22 over 441. We'll have our parentheses x minus the 10.5 squared and plus the 11.5 on the end. Now the fact that our a value is negative makes sense because our parabola was opening downwards. When a is positive, the parabola should open upwards and we should have a minimum. When it is negative for a, it opens downwards and we have a maximum. Now this problem will help you with homework question 3. The only difference on homework question 3 is they just tell us the points, the vertex and the other point in the question. It doesn't give you a graph where you have to pick it out. But if you have trouble on homework question 3, this question on the top of page 8 would be a good spot to look back at. All right, our last topic of review for this video is something that sometimes they end up cutting out if they are short on days with snow days in the first 2/3 of Algebra 2. So there's a good chance this topic might be brand new for you. It usually shows up on one question on the Regents. So parabolas can be defined in terms of what's called a focus and a directrix. A directrix is a line. In this course, we'll always see it as a horizontal line. A focus is a point. By definition, a parabola is actually all the points that are the same distance from that point and that line at the same time. So, for example, and again, this is the directrix. So the obvious point between them would be this one. That's going to end up being the vertex of our parabola. But if you pick out more points that are the same distance from the point and the line at the same time, so for example, like this random point here, it's the same distance from F as it is from the line. And every one of these points, so like the distance here would be the same as the distance there. So the parabola is defined as just all the points that are the same distance from the focus and directrix at the same time. The key thing that we need to recognize is that notice our vertex falls exactly in between the focus and directrix. So I like to show that by the letters F, V, D, showing the vertex is in between the focus and the directrix. Now, I want you to think to yourself all the different things that you have had for breakfast in the course of your life. And I want you to think if you have ever heard of a French vanilla donut. Odds are you probably have never heard of a French vanilla donut. But for the purpose of this, I want you to think of a French vanilla donut. And for the reason for that is French starts with F, vanilla starts with V, donut starts with D. So if you just think of French vanilla donuts, that will remind you that our vertex is always directly in between the focus and the directrix. And you'll see why that comes into play in a second. So they tell us our directrix is y equals -2. Y equals -2 is just a horizontal line at -2. Our focus is 0, 2. So let's plot that point and put an F. Well, because we know that we love for breakfast that imaginary treat of a French vanilla donut, we know the vertex is right in between the focus and the directrix. So we want to find that point that is directly in between, which in this case would be 0, 0. So based on what we did on the last few problems, since we know the vertex is 0, 0, we can write a lot of our equation right now. we're going to have y equals, we don't know what a is. We're going to have x minus 0 squared and either plus or minus 0 on the end. Now, we really don't need those zeros there because they're zeros, but I'm writing it this way for the moment just so you can see where they would go in the spots for the vertex, so you can see the consistency. Technically, because it's x minus 0 squared, that's really just x squared, and we don't need the 0 on the end. So really, right now in this particular example, we just have y equals ax squared. In a focus and directrix question, the a value will always equal 1 over 4 times p. Now you might be wondering in your head and asking your neighbor, what is p? P is the distance from the vertex to the focus. So our distance from the vertex to the focus, in this case, is 2. Now direction matters. If you go from the vertex up to the focus, P would be a positive 2. If you go from the vertex down to the focus, P would then be a negative number. So if P is 2 in this case, 2 times 4 will just give us 8 for the denominator. So that means our a value is just going to be 1/8. So our final equation for this will be y equals 1/8 x squared. Now these are really easy to check on the calculator. Let's go to a graphs page. Let's do a control doc and add a graphs page. We're going to put in our equation, our 1/8 x squared, and hit enter. And if you know the equation, which we now think we do because of our answer, you can get the focus and the directrix on the calculator. You can go Menu, Analyze Graph, Analyze Conics, and notice number 3 says foci. Okay, the single of that would be focus. Select foci. We have to touch the graph we want to find the focus of. So touch our parabola and notice the point 0,2 showed up. So that means that the equation that we found, its focus is 0,2, which is consistent with what the question wanted. So that part of it's good. Well, now let's check our directrix. We can do Menu, Analyze Graph, number 8, Analyze Conics, and notice number 5 is directrix. So we'll select that, touch the graph we want to find the directrix of, and notice the directrix shows up y equals -2. So those are both consistent with the information they gave us in the question, so we can be confident that we came up with the correct equation. If those don't check out, then you know you did something wrong, and you can go back and fix it. Now, knowing how to do this on the calculator can sometimes be a really easy 2 points on the Regents. There have been questions where they gave you the equation of the parabola, and you just had to tell either the focus or the directrix. Well, if you see a question like that, it should be a piece of cake. You just graph it on your calculator, you do what we just did, and the calculator tells us what it is. So we will see some of those when we start doing our actual Regents review problems. So if we go over to page 9, we're going to practice 2 more of these because, again, there's a chance it might be a brand new skill because it's often the first thing that gets cut if short on time from last year. So we want to write the equation of our parabola. We've got our focus and directrix. So let's draw on our directrix, y equals 1. So that's a horizontal line at 1. Our focus is 2, 3, so go 2 to the right and go 3 up. That's our focus. This is our directrix. Well, this morning for breakfast, I was really hungry, so I stopped at the store and I got myself a French vanilla donut. French vanilla donut is to help us remember the vertex is directly in between the focus and the directrix. So in this case, our vertex will be right there, and it is the point 2, 2. So let's write what we know about our equation so far. Y equals, we don't know the A value. To get to the 2, 2 from the origin, we went right 2 and up 2. If we want to go right 2, we would want a x minus 2 in our parentheses. And if we want to go up 2, we would just have a plus 2 at the end. Our A value should be 1 over 4p. Our vertex, we went up 1 to get to the focus. Because we went up 1, p is just positive 1. So if we fill a 1 in for that p, we really just get 4 times 1 in the denominator, so we get 1/4. So our final equation is just y equals 1/4 x minus 2 squared plus 2. We're not going to show the check for this one, but you could again graph it on a graphs page, menu, analyze graph, analyze conics, then select focus and then directrix to check and make sure that it matches what we have. All right, last one we'll look at on the bottom of page 9, and I should mention these problems on page 9 and the one on the bottom of page 8, they will be like homework number 4. So if you get stuck on question 4 of the homework tonight, these are great questions to look back at. So we've got a directrix of y equals 3, so that's a horizontal line at 3. We've got 2, -1 for our focus. Recall your French vanilla donuts, so the vertex is directly in between the focus and the directrix. So find that point that is right in between. That's our vertex, which in this case is 2, 1, because we went 2 to the right and 1 up. So to this point, we know we have y equals a. If we went 2 to the right, we'll have x minus 2 in parentheses squared, showing a shift right 2. And then if we went up 1, we'll have plus 1 on the end. Our a should be 1 over 4p. Well, from our vertex, we went down 2 this time to get to the focus. Because we went down 2, p will be a -2. -2 times 4 in our denominator will give us a -8 back. So our a value will now be -1/8. Then we'll have x minus 2 squared plus 1. When the actual parabola is drawn in, it opens towards the focus and away from the directrix. So that -1/8 for the a value makes sense because this one is opening down. Whereas in the last ones, it would have looked something like this, opening up, so positive a value would make sense. Again, you could check that answer, put it in a graphs page, menu, analyze graph, analyze conics, focus, or directrix, and you can check to see if those features match up. All right, so you know where to look from the in-class ones as you're trying the homework. So homework is on the next page there, page 10. Any time left in the period, you can be working on that, and have a great rest of your day.